Okay, so we're still in the groove of finding where the electrons are and how strong are they. What are they going to do, right? The main question in organic chemistry is what are the electrons going to do? And in order to do that, we need to find out where they are. Okay, so we find that we can save a ton of trouble by using line bond structures, a ton of trouble. But there are some shortcuts we don't want to do, and we really do not want to do. For example, we do not want to ever miss the formal charge because that's like a big red sticker in your problem, right? There's a big red sticker right there, big red sticker. And that's telling you what's going on with the organic chemistry reaction, right? So formal charges must always be drawn, but lone pairs are not always included. And it's here I borrowed the slide from our publisher. There, I wouldn't say often not included. I would say I draw them more often than not because I'm not always sure when I'm going to need them, right? So I'm sort of in the habit of drawing those out. And I recommend the same, although it's not, I would say, required unless the question stem says draw all lone pairs, right? Now, by knowing the formal charge, of course, you know if a lone pair is there or not, right? So if you see an oxygen with a formal charge of -1, then you know that there's 3 lone pairs of electrons on there. Again, I like to put those lone pairs there because they help me see what's going on, right? It helps me keep track of everything. So let's look at it like this. Oxygen has 3 possible bonding patterns. There's probably more than that, right? But 3 that we're going to see in nature, okay? The only 3 patterns are here. Wait just a second here. The same 3 patterns for any second row atom with 5, 6, or 7 electrons. Okay, so you can have 1 bond and 3 lone pairs. We did this with carbon in a recent video, right? 1 bond with 3 lone pairs, and that's going to give you a -1 formal charge. Prove it to yourself by doing a formal charge calculation, right? So we get our eyes used to this. It's going to be 1 bond with 3 lone pairs is going to be a negative charge, okay? 2 bonds, like with water, right, and 2 lone pairs is how we used to seeing oxygen, and so we expect that to have a formal charge of 0, right? And then 3 bonds with 1 lone pair is going to give you a formal charge of +1. All right, and we do the same thing for nitrogen, right? So with nitrogen, we're expecting things like ammonia, right? 3 bonds and 1 lone pair, we're expecting to have a formal charge of 0, right? And if we have too many bonds, then we have a formal charge of +1. If we have too few bonds, we have a formal charge of -1. All right, so get your eyes used to looking at those things. Prove it to yourself. Go through and do the formal charge calculation for oxygen, carbon, and nitrogen with an array of bonding patterns and get your eyes used to it. And you'll find it's going to serve you super well in the upcoming conversations.